1.4, writing equations, Algebra 2 with Trig. Make sure you have your note packet for Algebra 2 with Trig. 1.4, we're going to talk about a few different types of equations today. Slope-intercept, y equals mx plus b, something you've probably seen before. Point-slope form, you've probably seen that before as well, haven't used it quite as much. And same thing with standard form. Maybe you've been exposed to it, but we'll see how much that we have used it. Start off with a little review of slope. So in this case, it's change in, remember, it's change in y over change in x. My y's here, change in y over change in x. This would be change in miles over change in gallons. It's going to be a miles per gallon type of thing. And I'm going to do 66 minus 0 over 12 minus 15 gives me 66 over negative 3, which is negative 22. So the rate of change is negative 22 miles for every gallon of gas, which means you're burning gallons of gas, which should make sense. That's what the negative gives you there. More often than not, we would talk about a vehicle getting 22 miles to the gallon. Rate of change here, we're going to be using these things again, but all we have to do here is find yourself one point. I can't tell for sure another point. I'm going to go right here. So I'm going to go down 2, right 1, 2, 3, 4, 5, 6. Down 2, right 6. I should have read it as negative 1/3. Looks like I missed one right there. That would have been fine, but you know, more than one way to do it. So I have a slope of negative 1/3. Okay, here's our different forms we're going to talk about. Those are the three forms we have, and then we're also going to talk about parallel lines and perpendicular lines. We should remember parallel lines, they have the same slope, and then we have a special case for perpendicular as well. First one, slope-intercept form. That's going to be y equals mx plus b. So what do I need to write down? Probably this right here. Y equals mx plus b. We calculate the slope. We did that change in y over change in x. That was from yesterday. y2 minus y1 over x2 minus x1. Y-intercept comes at the point 0, comma b. Figure out where it crosses the y-axis. That's why we call this the slope. The m-intercept is the b. So the name of the equation actually comes directly from what you get from the equation. What is the equation for each line? I want to identify a slope and I want to identify a y-intercept. Y-intercept here is 4. I get a b of 4. Slope, I'm going to find a couple of points. I got one there. I got one there. Down to left 1 or up to right 1. You can look at it either way. If I go up to right 1, I get a slope of 2 over 1. Very easy to write. Y equals 2x plus 4. Over here, y-intercept of 1. Find a couple of points. If I look for an exact spot, I kind of see it. Let's see here. No, maybe, no. I see it there. You see it there? No, I think it's there. I see it there. Let's see if these line up, eh? Let's see, I would go down 1, 2, 3, 4, 5, right 1, 2, 3. I get down 5, right 3. Let's see if that lines up. 1, 2, 3, 4, 5, 1, 2, 3. Looks good to me. Equation will be y equals negative 5/3 x plus 1. Remember a couple of quick checks here. You're going up from left to right over here. Slope needs to be positive. Going down from left to right here. Slope needs to be negative. You can kind of check that even before you started. You could have told yourself whether the slope would be positive or negative. A couple more. I got I got a b here, I got a b of 3, and I've got a slope of down 2, right, 1, 2, 3, 4, 5, 6. That's very similar to the one we just saw. So if I have a slope of down 2, right, 6, I've got a slope of negative 1/3. Well, the equation is y equals negative 1/3 x plus 3. Again, down from left to right, you can check that out. So these are really nice when the y-intercept goes through a nice point. They're not, y-intercept won't always go through a nice point, but most of the time we're going to have our equation go through at least one point, and that's where we want to use point-slope form. So what we're looking at here, again, the name of it actually tells you kind of what you're doing. The slope is going to be m, and then there's another point, any point, x1, y1. It does not need to be the y-intercept. So we read this as, again, this is going to be the change in y over the change in x, and then this x1, y1, that's the point that it's going through. That's the point that it's going through. So this is what you need for your notes on the point slope form. Okay, I think you got to turn the page on your notes. We've got a graph at the top there. We're going to read these in point slope form. It is very important that you understand in point slope form that we are subtracting the points. So that, whoops. We are subtracting the points. So when I write in point slope form, we need to recognize that it's y minus y1 equals m times x minus x1. So this top one, if we take a look at the top one first, if we take a look at this one, this my x point, y point, my slope is obviously 2, and then my point for the point slope, you got to be careful now, x minus positive 4. The x value is actually positive 4, and the y value, y minus negative 7. This would have to be minus negative 7. That's where the plus came from. So the point is negative 7. So it's almost an opposite idea. So if I'm going to graph that one, I'm going to go 4 right, 7 down. And there's my point. From that point, I apply my slope. So I don't have a y-intercept here. Well, I'll have one, but I don't necessarily see it on my graph. And I go up 2, right 1, up 2, right 1, up 2, right 1, up 2, right. How far do you really need to go? That's probably more than enough. I could also go the opposite direction. And then we get a nice straight line. I can't draw straight lines very well on here. I'm going to do the best I can. Make sure you get arrows at the end. So the y-intercept is going to be somewhere way down here where these two things intersect. I don't necessarily know where it is, but I have enough information to graph. And that's what's great about it. You're picking apart the point and you're picking apart the slope. If we graph this guy now, pretty easy to see. The m is equal to 4, and then the point x minus x1. So taking the place of the x1 is going to be positive 1. Y minus y1, taking the place of the y1, is 3. So you got to watch out for those negatives. That's probably the one thing that is going to be the most, can be a little bit tricky. They can trick you sometimes. Don't get tricked. And I go 1 right, 3 up. And then I apply the slope from there, slope of 4, up 4, right 1. I could go the other way, down 4, left 1. Ooh, look at that. It had a nice y-intercept. And now I connect my dots the best I can. And I've got not bad. I'm doing okay. Now, how do we change these things if I really wanted to know what if I really wanted to put it into y equals mx plus b, you can distribute the 4 and solve for y. So you can zing it over to y equals mx plus b pretty quickly. But when they're in this form, plot the point, apply the slope. That one could be changed around too. The other one could be changed around too, and you could find that it's actually going to be, I think it's negative 15 for a y-intercept on that one, which would not be conducive to graphing. So find the slope, find the point, plot it, apply it. Write the equation of the line. So you're going to be using y equal, you're going to be using y minus y1 equals m times x minus x1. Here's x1, y1, here's m. Plug them in. Y minus negative 2, that gives you a plus. It's kind of an opposite idea, is negative 3/5 times x minus 5. I can graph it just how it is. Plot my point, 5, negative 2. Apply the slope of negative 3/5. That's going to go this way. Up 3, left 5. Up 3, left 5. And I have, whoa, did I do that? I didn't go up 3. Should be that one. And, oh, that's a terrible line. That's a I can't draw a straight line. You can do a better job on your paper than me. Now, if they wanted this is technically correct. If we wanted to turn it into y equals mx plus b, I distribute the negative 3/5, and then I subtract the 2, and we get negative 3/5 x plus 1, which somewhere in here is my y-intercept of 1. So, good stuff. Same thing here. Write an equation. Y minus negative 1 equals m times x minus negative 3. So you got to watch out for those negatives. Plot the point, negative 3, negative 1. Apply the slope, up 2, right 3. Up 2, right 3. Draw a line. I did a little better that time, and we get our equation. If I want to rearrange it, I could distribute. This would be fine. Okay. Let's take a look at this one, because the first thing, we have 2 points. And the first thing I want to do is find the slope. I'm going to go y2 minus y1 over x2 minus x1 gives me 10 over negative 5 or negative 2. So I have a slope of negative 2. Now here's the big question. For y minus y1 equals m times x minus x1, does it matter which point we use? And the answer is no. You could use y minus negative 3 equals m times x minus 2, or you could use y minus 7 equals m times x plus 3, x minus negative 3, which is plus 3. Both of them will work, because if you watch, if I go 2, negative 3, that's the point. Apply the slope of negative 2, up 2, left 1, up 2, left 1, up 2, left 1, up 2, left 1, and so on and so forth, up 2, left 1. If you take a look at where is negative 3, 7, there it is. I go right through it. So I think using the 2, negative 3 is probably a little easier just because it stayed on the graph. But this is what my graph looks like. Either of these would be acceptable. And if you rearrange both of these, you will end up with exactly the same y equals mx plus b. We will end up with y equals negative 2x plus 1. If you rearranged either of these, they both end up with the same y equals mx plus b. So given 2 points, it's often easier to write the equation of the line in point-slope form and then just transform it over to slope-intercept. Standard form. Standard form. Let's talk about standard form. So here's what you need. You need to have ax plus by equals c. So a, b, and c are numbers that are not 0. Because if there's 0, then we have or the 0 can be, c can be 0, but a and b cannot be 0. A is also, you need to manipulate it so it's positive. A must be positive. And then the other thing is a, b, and c are integers, okay? No fractions and no decimals. And I think there's one more here. Did I miss one? Yeah. And they are reduced. Reduced. The greatest common factor is 1. Whoa, whoa, whoa. So they need to be simplified. Now, what does that mean? Like if I had 2x plus 4y equals, it's not what I meant to write. I'll get there. If I had 2x plus 4y equals 6, the greatest common factor would be 2, and they all can be divided by 2, and you would simplify to x plus 2y equals 3. So that's what it means to be. So you got to be, A's got to be positive, A and B can't be 0, they got to be whole numbers and integers, and they need to be reduced. So if you manipulated this around, if I solved ax plus by equals c for y, I'd subtract the ax, and I would divide by b, and then you can pick this whole thing apart. Negative a over bx plus c over b. So you can find y equals mx plus b right here. So you can just pick these things apart if you want. And that's what's called reading the slope-intercept. Negative a over b gives you the slope. C over b gives you the y-intercept. Parallel lines have the same slope, different y-intercepts. So if you know the slope of one line and you know the slope of then you know the slope of a parallel. Perpendicular lines, their product is -1. They are opposite, what means change the sign, reciprocals. Opposite reciprocals, 3 and -1/3. They have a product of -1. So if you multiply them together, you get -1. So if I have -2/3 as a slope, it's perpendicular slope, and I like to write perpendicular slope, that's the symbol for perpendicular, upside down t, would be equal to positive 3 over 2. Flip them over, change the sign. That's perpendicular. Write an equation in slope-intercept form for the line that passes through 3, -2, and is perpendicular to the line whose equation is -1/5. So here's what I like to do. Identify this slope as -5. Identify the perpendicular slope, change the sign, flip it over, positive 1/5. I'm going to use a point, I'm going to use a slope. Y minus y1 equals m times x minus x1. That's an equation, but it's in point slope. I'm going to graph it using point slope. Now I'm going to apply 1/5, up 1, right 5. I'm off the screen, down 1, left 5. Connect the dots. Okay, they did say they wanted it in slope-intercept, so now I need to distribute. Y plus 2 equals 1/5 x minus 3/5 minus 2 minus 2. Y equals 1/5 x, yuck, minus 2 3/5. This is a great example of finding -2 3/5 and applying a slope would be a bad idea. That's why we use point slope. Point slope can be much easier. Last one, write an equation that passes through 3, 5 and is perpendicular to the line whose equation is given. Again, if this was parallel, I would just use that slope and that point. It's perpendicular, so I'm going to identify the perpendicular slope would be negative 1/3. So I'm going to do y minus 5 equals negative 1/3 times x minus 3. I'm going to go 3, 5. And now I'm going to apply the slope. Down 1, right 3. Up 1, left 3. That's enough. Graph the line. If they want it in slope-intercept, I can distribute. Y minus 5 equals negative 1/3 x plus 1. Add 5 to both sides, and I get this, which I'm going through 6, which is great. Should be here. Almost made my first mistake of the year. Okay. Good deal. Good deal. Okay, there's our homework. They're going to ask you to probably do some graphing on 25 through 28. They're going to do some other graphing. You might need a little bit of graph paper. If you write nice, that's great. You can graph your own. Otherwise, grab a piece of graph paper with a bunch of grids on it, and you can get her done. Pause that, write that down, and we're good to go.